so number 4 from the optimization homework said that we had a semicircle with a radius of A, and we were looking for, I believe it must have been the max area of a rectangle inscribed within that. Is that right?
Yeah.
Okay. So first thing we need to know is we need to write the equation of a semicircle. So the equation of a semicircle, oh, that was not a very good looking semicircle. That is not either. It's really hard to draw on this laptop screen. We're going to pretend that's good. The equation of a semicircle is y equals the square root of the radius squared minus x squared. That just comes from, the equation of a circle centered at the origin is x squared plus y squared equals r squared. So, if the radius is a squared, right? And so if you solve that for y, you get a squared minus x squared inside of a square root. The positive square root is the top half of the circle, and the negative square root would be the bottom half of the circle. Okay? So that's where that equation comes from. You should, I hope, already have been familiar with that. But so this is the function y equals a squared minus x squared, and we're going to inscribe a rectangle into it. Maybe. So laying flat across the x-axis and with vertices that touch your semicircle. So the height is just whatever y value we've gone up, depending on how far over x we've gone. Right, at this point there would be x comma y, or x comma root a squared minus x squared. So this, it being a semicircle, we know it's symmetric across this y-axis. So this distance here would also be equivalent to x, which makes the length of the rectangle 2x, and the height, or the width of the rectangle, equal to y, or root a squared minus x squared. So the area of that rectangle would be 2x root a squared minus x squared, or length times width. Everybody good with that so far? Hopefully so. All right, so then to find the max, we just take a derivative. So a prime, and this is a product rule. So 2x times the derivative of root a squared minus x squared, which is 1 over 2 root a squared minus x squared, times the derivative of a squared minus x squared. Well, a squared is just a constant, right? A is a constant, it's just the radius. So a squared is a constant. The derivative of a constant is 0. So we multiply it by just the derivative of the negative x squared, or negative 2x, and then plus derivative of 2x root a squared minus x squared. So I had a lot of people in the last day or so asking me about this one, having trouble with A. A is a constant. So when you take its derivative, it's just 0. Then we could cancel out some 2's here just to make life a little bit easier. Cancel that 2 with this 2. And we're going to get a common denominator down here. So a prime will be equal to negative 2x squared plus 2 times a squared minus x squared over root a squared minus x squared. And so we ended up with that because we just multiplied this by root a squared minus x squared over root a squared minus x squared. And that effectively squares that, or gets rid of that square root sign. And so what do we end up with up here in our numerator? We end up with negative 2x squared minus another x squared sorry, I forgot my 2 out there, minus another 2x squared, so it'll be minus 4x squared, and then plus 2a squared over this root a squared minus x squared. Everybody good with that one so far?
Yep.
Okay. And so then we say, all right, when does this equal 0 and when does this undefined? Well, it's undefined when a squared minus x squared equals 0. But if a squared minus x squared equals 0, that would mean that the width would be 0. And we're not going to have a width of 0. So that doesn't make any sense. So we'll just look at when the numerator is equal to 0. So that'll be when is negative 4x squared plus 2a squared equal to 0. And that gives you 4x squared equals 2a squared, or x squared equals 1/2 a squared, or x equals plus or minus the square root of a squared over 2. The negative isn't going to make any sense, so positive square root, that's a over root 2. So that's either a min or a max. And since we don't really have a nice, a nice numeric value to plug in, it makes it a little bit more difficult to plug it into your first derivative. So you might want to use a second derivative here. So a double prime, let's see, a prime was this, right? So a double prime will use the quotient rule to find. So that'll be root a squared minus x squared times the derivative of this, which is just negative 8x, minus that numerator, negative 4x squared plus 2a squared, times the derivative of root a squared minus x squared, which is 1 over 2 root a squared minus x squared times negative 2x. And then all divided by our denominator squared. Our denominator was root a squared minus x squared, so that just becomes a squared minus x squared. Then we got to plug in our a over root 2 value into this, which is not super pleasant, but we're going to plug that in for our x values. So we end up with what? A squared minus a squared over 2 inside of our first square root. So a squared minus a squared over 2 is just a squared over 2 inside of a square root, which is a over root 2. And then times negative 8a over root 2. So negative 8a squared, and then another root 2 down there. And then these negatives right here will cancel out. So really, we're going to have a plus, and I'm sort of running out of room here. So we'll finish out some of our evaluation on the next page here, but I'm going to have a plus 2x times this, which will be negative 8x cubed, and a positive 4a squared x over my 2 root a squared minus x squared over my a squared minus x squared. So I'll plug the rest of the x, plug this in for that, and the rest of it, I just needed some more room to do it. So let's see here. So we have negative 8a squared over 2, or negative 4a squared. And then we've got, let's see, if I cancel out the 2 here with these, that's a negative 4x cubed, and then that'll be a cubed over 2 root 2. So if I plug in x cubed, so I have negative 4a cubed over 2 root 2. Next piece of it, if I divide this by 2, that's 2a squared times x, so 2a cubed over root 2. And that's a plus, so plus 2a cubed over root 2. And then that's all over root a squared minus x squared, which we already figured out. Root a squared minus x squared was equal to a over root 2, I believe. Is that right? A squared minus x squared. Yeah, that's just a over root 2. So we'll simplify that in a second. And then in the very bottom here, we have a squared minus x squared. So that's a squared minus a squared over 2, or that's just 1/2 a squared, or a squared over 2. Everybody good with that so far? It's a little bit of a pain.
Yeah.
But could be worse. So let's see here. 4 over 2 root 2. Well, the 4 and the 2 can cancel into just a 2 and a root 2. And 2 over root 2 is just a root 2 in the numerator. So now we've got negative 4a squared minus root 2 times a cubed plus another root 2 times a cubed, all over a over root 2 over a squared over 2. Hold on one second. Okay, sorry about that. So the minus 2a cubed plus the 2a cubed is just a 0 there, looks like, right? So that part's going to cancel out. 0 over a root 2 is just 0. So we got negative 4a squared over a squared over 2. And if we simplify that out, that becomes negative 4a squared times 2 over a squared, which is negative 8. And since negative 8 is less than 0, that tells us that it's a max. Good or no?
Good.
All right. Fun times, huh? It's a good one. All right, other questions from the optimization?
Number 7, I kind of just dismissed that there was a triangle and just dealt with the rectangle, and I know that's probably not right.
Is that the window problem?
Yeah.
Yeah, that's not right. Okay, so here's your rectangle. Here's your triangle. There's your triangle sitting on top of it. We'll say this is X. We'll call these Y. If this is an equilateral triangle, then those are also X. And the area should be equal to X times Y plus the area of this equilateral triangle, which I think is convenient and helpful if you just know the formula for the area of an equilateral triangle, but you can also use right triangle trig to figure it out. But it's X squared root 3 over 4. So that might be helpful to just memorize that. So then we need to figure out what Y is in terms of X. I think we're given that the perimeter is equal to 12. Is that right? I don't have it sitting in front of me right at the moment, but was the perimeter 12?
Yeah.
Yeah, okay, so perimeter is 12. And so that's equal to X plus another X plus another X, 3X. We don't include this one because that's not part of the perimeter. Right, so 3X plus the 2 Y's. So we should be able to figure out what Y is equal to. Right, we got Y is equal to 12 minus 3X over 2. So we'll just plug that in here. So we have X times 12 minus 3X over 2 plus X squared root 3 over 4. And if we want to distribute that X in, that's probably makes life a little bit easier. That becomes 12X over 2, or just 6X, minus 3X squared over 2 plus X squared root 3 over 4. Good or no? So far? All right, so A prime then is just equal to 6 minus 3X. If we take the derivative of 3X squared over 2, that's 3X. And then this one becomes 2X root 3 over 4, or just 2X, or just X root 3 over 2. And if we want to find out when that's undefined, that's never. But if we find out when it's 0, that ought to give us at X equals negative 6. So bring the 6 to the other side. And then we factor out this negative 3 plus root 3 over 2. So divided by negative 3 plus root 3 over 2. Good with that so far? Is that Evan that was asking this, right?
Yeah.
Yeah, good with that so far?
Yeah.
Okay. And then from there, you can either use a sign chart or a second derivative test. I'd use a second derivative test just because it's pretty easy. 6's derivative is 0. This one's just -3. -3 plus root 3 over 2. Well, -3 plus root 3 over 2 is negative, which tells you that you have a max when x equals this. And I don't know exactly what it asked for. It might have asked for the exact area or the whatever the dimensions. You can plug this in to find y, but that's the x value that the max occurs at. And I know this looks like it's negative, but it's not. Top's negative, and -3 plus root 3 over 2 is negative. And so divide them, you get a positive. Does that make sense, Evan? And everybody else that might have had a question on that one?
Yeah.
Cool.
Hold up, can you keep it up for a little bit?
Yeah, sure. Yeah, no problem. I mean, at least enough time for you to, write it out and resubmit your answers, right?
No, I already submitted.
I know, that's why I said resubmit. I'm just joking. Ha, it was very funny, I know. All right, anybody else have any questions on the optimization problems?